want me to connect this? Or do you want me to connect this somehow? You have a big screen.
What?
You have a big screen, much larger than mine.
It's a workhorse.
Yeah. Why is that? Is this connected already? It is.
It should be. I don't think it's on, right?
Here, wait. We'll extend a little bit after midday. We'll extend a little bit.
Let's see how much I have anyways.
Yeah. Tá bem, e como é que é de inverno?
Agora está bem, tem que chegar lá acima.
Do you need to press the button?
Yeah, I think.
If I jump, maybe. Let's try to wait to the Okay. Teamwork.
Okay. Let's see. Okay. Is it on you? Okay, everyone, welcome back. Sorry for the delay for those who are online. We'll have now two hands-on sessions about scientific data visualizations with Maki.jl. The first one about plots, animations, and graphics, and the second one about visualizing Earth observation data with Tyler.jl. These hands-on sessions will be carried out by Simon Danish, and Simon is the author of Maki and currently works full-time on Maki as a freelancer. He has been part of the Julia community for more than 10 years and is the author of many Julia packages. To just name a few that are still actively used by many people in the Julia community: Maki, Geometry Basics, GPU Arrays, Package Compiler, JSS-Surf, and File.io. His mission has always been to create a sustainable plotting and graphics ecosystems for Julia, which enables visualizations in need of high performance, as well as making it very easy to quickly create simple plots and integrate them into dashboards. Nowadays, with climate change threatening to destroy the fundament of our modern life, he is focusing his efforts on making sure that Maki works well for climate science to better understand the changes that are coming to us. Thank you.
Thank you. Hi, everyone. I guess I can skip the about me part. I just wanted to quickly say that I'm part maintainer of Tyler and GeoMaki, but I'm not that much into the geospace myself. It's just because I want to keep the ecosystem alive, but I don't actually work that much with it because I'm really have a lot to do to keep Maki working. About the workshop, I'll start with a basic introduction to Maki and tell you a few of the basic concepts. And after that, I will talk a bit about plotting geodata. But I have to say that I'm not the specialist for geodata plotting, because, yeah, my main job is actually the graphics inside Maki. and make that work in a fast way on the GPU and stuff like that. I will also show you how to build apps with Bonito. I just recently finally renamed that, so it was formerly named JS Surf. I presented that at last Julia EO. It's for making dashboards with Marquee in the web. And I tried to reference a lot of the documentations everywhere in this workshop, so you can read through it later on and have a lot of starting points where to look for things. Now first, what is Marquee? It's a modern plotting library for Julia. It's modern because it runs fast on the GPU, uses a modern programming language that's easy to use. And of course, we try to also make Marquee easy to use in a high-level language. I really try to have a large scope for Marquee so that you can use it for almost any problem, which has the advantage that you can use it for most things, but of course it's not as polished in some areas as a specialized tool for it. But I think for a plotting library, this is especially powerful because you really just want to have one tool and do all your visualizations needs with that, because it's really hard to learn a whole plotting library and switch it all the time. Marquee by now has a really rich ecosystem. Just want to quickly scroll through the new Marquee webpage. I think it's a good resource for everyone to have an overview, like what's it doing, how it works, and yeah, get an impression what you can do with it. And I also reference quite a few of the Marquee plugins or packages that build upon Marquee. You already heard there's Tyler, which I will be presenting a bit, and yes. But I think you can already see here that there's quite a lot of different use cases you can use Marquee for. And this is mostly enabled by having different backends for different special purposes. So all the plotting code, like how to get from a heat map to like apply transformations to it and stuff like that, all of this is defined in Marquee.jl, but how to actually draw this on the screen is defined by the backends. So you can have really fast GPU accelerated drawing of plots, but also can export it to a vector graphics for papers and stuff like that. And that's enabled by backends. And I will quickly give a short overview about the backends, because that's the first question, like which backend should I use for my project? And yeah, the first backend I've written, which actually goes way back before I even wrote Marquee, because I reused a lot of the code from even older libraries. It was first called glvisualize, and before that it was called glplot. And then I thought maybe I need a new package where I have different backends, because not everyone has a GPU. You probably want to use it on the web with a completely different infrastructure. But this is also why it's the most feature complete and the most polished backend. It's really fast, and you even have basic UI elements like buttons, sliders, and things like that. But yeah, it needs a GPU. It doesn't run everywhere. But on Linux, for example, it's relatively easy to set up a virtual GPU on a server, for example. The next backend that we developed uses Cairo under the hood. It has a really amazing 2D rendering quality, can export SVGs and PDFs for papers. It has a bit of 3D support, but it's still experimental. So you can do surface plots with it and stuff like that. but sometimes it won't look as nice as in geomarchy. It's not interactive, so you really just render out SVGs or PNGs, but you can still loop over these steps and make a movie out of it and stuff like that. And it runs on the CPU, so it basically runs anywhere without any problems. WebGL Marquee is the next backend that I started developing like 4 or 5 years ago. It is there to export marquee plots basically to the browser, use it in notebooks like here. You can also, it also enables to view it in VS Code in the plot pane, because that's actually using an Electron under the hood. It is also pretty fast because it uses the browser OpenGL implementation, but it has quite a bit of overhead to actually transfer the data from Julia to the browser. It's pretty feature complete, but some basic things are missing, like it doesn't have really nice line rendering like geomarchy, so you may run into like lines that look a bit rugged, but yeah, it runs on websites, notebooks, and remote machines. And that's a little dashboard that runs on a website. So you can do stuff like that. And the nice thing about this is you can use any HTML or JavaScript to build UI elements for it, to do interactive dashboards. And then finally, the newest backend is the Radeon Pro Render backend. It uses ray tracing and makes really beautiful images, but I didn't really have a lot of time to polish it yet, so it still has quite a few bugs. But Lazaro is using it already a lot to create beautiful images. Also for his website, Beautiful Marquee, which I've linked in the notebook. It's really slow because it really simulates the light photorealistically, so you need high-end hardware to make animations. Now, this is a notebook which you can also run locally. I usually prefer to just concentrate on the presentation and then run it at home or try it out, because you may run into problems and it always slows down to just go around and set everyone up. So I don't really expect you to follow it, but if you have it running, it's relatively easy to set up. I also have a little description to how to add Julia, because I'm using 1.10, which is a lot faster for pre-compilation. So if you've struggled with slow compile times during the workshop, I would recommend to upgrade to 1.10. Especially for Marquee, I think it's almost double as fast to compile things and start things. And yeah, then you just add iJulia and start Jupyter Lab in the folder where you downloaded the notebook. And then you're in this screen. The first thing you will do is activate the project I shipped, which already has all the packages that I want to present here and work with. And some of them have just a very small role, so we are not talking about all of them here in detail. And for this workshop, I'm using WebGL Marquee because it works in the notebook and the browser. I don't usually work a lot in notebooks, so I found a few issues while preparing the workshop. One really annoying one: if you define a heading which is called Bonito, Jupyter somehow creates a global JavaScript variable that overrides the package. So I found that out yesterday because my notebook wasn't working anymore. The plots weren't showing up. And it's because I added a headline with bonito. So don't add headlines or a title, with bonito. So that's really crazy. WebGL Marquee also seems to be a bit slower in Jupyter, which is also surprising because it uses exactly the same technology stack than in VS Code, for example. Or one other way to show WebGL Marquee plots is directly in the browser. So they will show up here in a new tab. And it's actually quite a bit faster than in iJulia in Jupyter Lab. I still need to look into that. But yes, just a few warnings. But then when using a backend in Marquee, it will activate it as the default backend. And you can switch between them by just calling the backend and then activate. Wow. So we'll be activating WebGL Marquee. And there are also documentations for this activate function because you can actually pass configuration options to the activate call. For WebGL Marquee, it's not that much. It's basically just the frame rate at which it renders, and that you can actually set it to resize to like an HTML element, which is specific to WebGL Marquee. If you look at the documentation for GL Marquee, it will be a lot more because it has actually quite a few configuration options. But yeah, I won't go into detail for this workshop. Okay, let's start with the very basics of creating a plot in Marquee. So the main, most top-level object in Marquee is the figure. It holds the layouting. It holds any axis you put in there, and blocks and scenes. I will talk a bit about blocks, but it's the super type of all things like a legend, a button, a widget, and an axis. So that's the general term, basically. I won't talk much about scenes, but because sometimes you might run into it, I'm mentioning it here. It's the most low-level building block that you won't run into usually. You can imagine it like the native drawing canvas for Marquee. But it is really, it can be really powerful because you can just draw anything into it and switch from a plotting library basically to a more drawing library. But yes, this is how you create your first axis. You just index into the figure at the position you want to have the plot in. So I'm creating an axis in position 1, 1 and 1, 2. So you have two axes next to each other. Oops. And adding a new axis is then pretty easy. You can just put it next to it or under it. You can see that you can just pass a lot of attributes to the axis to customize it, like titles and labels and stuff like that. For the figure, the main parameter is the size and the background color. And the rest of the arguments will become a theme for Marquee to use. I will explain that a bit later. But before that, I want to show you how you can actually figure out how to tweak your axis. So there's a docstring which you can access like this. In the REPL, it's also just typing the question mark. And I think in VS Code, you can just hover over it and things like that, or go to the REPL. But that shows you basically all of the attributes you have for axis. And then you can zoom in on it, like you're interested in, for example, like what can you do with titles in an axis? And then you can do this axis.title thing and get more documentation for this specific attribute. So here you can see that you can use LaTeX strings for a title, and there's also this rich text we added to Marquee, where you can basically do pretty complicated text layouting with coloring parts of the text. And one of my next projects is to make this interactive, this help, so that you have a little pop-up where it actually shows the resulting plot of this example, but right now you would need to copy and paste it and run it, this example, and then you can see here 3 axes, one with a normal title, one with a LaTeX title, and one with a rich text title. Yes. I already mentioned theming for a little bit. I think it's almost an advanced topic, but I want to set a little theme for this workshop. So I should mention it in the beginning. It's really just any dictionary-like where you set some defaults for any attribute in a plot. So for example, for this figure we had here above with the background color, you can just set that here accordingly in the theme. You can globally set a size at which each figure is created. And you could, for example, for any scatter plot, you could also set the marker size. And for any block, so axis, legend, etc., you can basically do a sub-theme where you just add the attributes that you would usually pass to the axis directly. And the same goes for plot types. So you can just have a sub-theme here to always make line plots of width 4. And there are several different ways of setting that. So there's a set theme function that sets it globally, so any plot will have this theme applied that you create. You can also do it in this do-while block, so only plots created in this do-while block block will get the theme applied, and after that you will have the default theme. And you can actually pass these theme attributes to the figure directly, and then only this figure will have this theme. When I execute this here, I will be setting this globally, this theme. So the next plot I'm doing has this silver background color and always has a title with Marquee Workshop. By the way, you can always ask questions if I'm too fast or anything is not comprehensible. Yes.
So, I have a curious question. When you create the axis and you index the figure at 1, 1, would it also make sense to create just the figure object when you say axis, parenthesis, F1, 1? Would you just pass F? It would make sense or no? Like, would it be a good feature addition or?
You mean like this?
Like axis of F, right? Has something like, I'm not seeing, yes, exactly like this.
You can actually do that.
Okay.
Then it shows up without position, and then you can actually assign it to a position.
Yeah, because my intuition, for example, for a very beginner, right? The beginner would expect maybe that this would already be assigned to 1, 1, maybe somehow go back to do exactly that, yes. Would that make sense as like an additional?
I'm not sure. I will be discussing like a few shorthands later on, and I think the shorthands already cover this in a way. I mean, it's different, but I mean, your idea is to have less, to write less, right?
Yeah,
So I think that's,
For like very beginners, maybe they would try to just create an axis on this figure. Like,
yeah. I will show that. But yeah, if you have a axis, then you can plot into that axis, and it will use that coordinate system and the transformation of an axis, etc. And it's always the version with a bang of the plotting function, because you actually mutate the axis. You add a new plot to it. There are a couple of shorthands to create this in one line, basically. So the plotting function without the bang can create this whole thing at once. So you can actually create this whole plot with an axis and a figure in one line. And then you have these attributes here that you can pass to the plotting function, where you just pass the attributes of a figure or axis to customize it. So here you could say my title to actually create change the axis. There are a couple of these. So you can directly plot into a figure position, and it will create a new axis for you. We had this one already, where you plot into an axis, and then just for completeness, you can also directly plot into a scene. But it's pretty low level, and I don't think you will see this unless you have more advanced use cases. The next thing I want to talk about is how to color your plots. There are quite a few different ways how to pass colors. So the first one is you just color the whole plot with one color. So you pass one color to the color attribute in the plot. It supports quite a few different ways of defining the color. So you can use like these CSS names for colors, which are parsed and converted to a color. You can directly call like this RGB type, which creates a color in a more low-level way. And I have a few pointers where you can actually get those names from. So the colors.jl documentation has a really nice page to get like these color names. So for example, here there's light cyan, and you can then immediately use that in Marquee. And you can also use, not just use RGB, but Marquee supports all color types from the colors.jl package. Oh, wow. Which is quite a lot. So all of the main color spaces, I think, that are in use, so HSL and stuff like that. Yes. Yes.
For example, is it possible, for example, like sometimes we want to have there's always like, for example, the color map is views, for example, but we don't. But when we specify, and then we specify maybe 15 colors, but we actually only want to use 11 out of the 15 colors. Is it possible to select a range? Because sometimes the color map, for example, the light is very light and the dark is very dark, and color you want something that is in between. So I do is I specify like 20 colors, and I only I usually specify 20 colors, and I only ask for like the middle 10 or the middle 15. Is it possible to do that?
Yes, so you can use, Marquee has this conversion infrastructure to go like from strings to actual colors. And you can hook into that. There's this toColorMap function, which generates the actual array of colors from a color map name. And then you can do like 3, 2, something like that. And then you can actually use that. And yeah. Oh, this is a bit too big. But yeah, the next thing you can do is like have one color per primitive in the plot. So in a scatter plot, that's one per point. In a line plot, it's one per line point. So you can also have like a smooth interpolation there. Yeah, and then we already started talking about color maps. You just give the color argument the numbers you want to get mapped to a color, and then you give the color map argument with the actual color map that you want to use. But you could also give it an array of colors. And the array of colors, again, supports all of colors.jl, color types, and all of these CSS color names. Yes, and the color map also has like a few more attributes. You can give a color range to like cut it, and then you can give it a color if you're under the color range in your numbers, and above, which is like the low clip and high clip one. You can give nan colors, nan numbers in the colors, a specific color. And then if you look at that, so we have low clip red. I have a range for the colors from 1 to 10. So the first two will be red. Then it will be the color map. Then I added a few nans to the color, and made them orange. So you have two orange colors here. Then still values from the color map. And finally you have the high clip in black, which is above the color range. And here I also show you how you can interact with the axis. So any attribute in the axis you can just set interactively.
Sam, another question, because you said there are none colors, NaN colors. Is there also colors for missing data?
No, so Maki actually doesn't support, oh no, it does support missing. It will convert to nan, and then nan color should apply. Yes. So here I show how you can mutate the axis to give it different Y ticks. So here I have these labels I gave to the plots as the ticks for the Y axis. So here's the simple CSS color, etc., etc. Yes, Maki also has pretty elaborate color docs. And cheat sheets and stuff like that. So if you're lost in how to give your plot nice colors, Maki has quite a bit of documentations about what you can use. And I usually visit this website to find a nice gradient to use, because you can see it here nicely laid out. There's also a dictionary of all the accepted color names that you can consult if you're not sure, or if you want to like pick them. And similarly, there's all gradient names, which is 2030 elements. So you can choose from quite a lot of gradients and create your own. And yeah, I already showed that you can use all these different official color spaces. I think this is especially interesting if you have data in that color space from, I don't know, from a satellite, for example, if it comes in a certain color space. Maki will understand that. And of course, if you're talking about colors for plots, I think the next important thing is how to actually create legends to map the plots to some more description. And one very simple thing you can do is call this axis legend function on the axis. It will search for any plot inside the axis with a label. So that's why there are all these labels in here. And then it will create a legend for that. You can place this pretty freely. It's also shown in the axis legend docstring. But you can also create the legend manually in a certain position in the layout. So here I do the same by placing the legend next to the plot. And I'm also hiding the Y labels because now we don't need these labels there because they're redundant. That's just a convenient function to set like x dot tick labels visible equals false, and then x ticks equals false, and so on. And Maki has a few of these shorthands, which you can also find in the access docs. So I think I don't have enough time to go all over this, but there's a lot you can learn in the docs about interactions with the axis, like how you zoom, how you register new interactions with the axis, how to set aspect ratios, and what all these parameters mean. Yeah, the legends are also very flexible. I won't go much into detail here as well, but as you can see in the linked docs already, like you can basically create any legend with any layout you want, and you can even have custom markers and stuff like that. So I'm pretty confident that you will be able to create any legend you want with this. Color bar works quite similarly, as you already can see here. For the examples that actually use a color map or multiple colors, it falls back to just black because you can't just represent a whole color map into one point. And that's where you likely will want to create a color bar instead. I just quickly made an example here that shows this for the example which set the low clip and high clip. And you can also see this in the color bar here. That's the low clip and high clip color. I already show here a bit that you're pretty free to place this legend with the Maki layouting system. So you can actually put any block object into the same position as another axis, for example, and then you can position it with these additional arguments. And that's how I made it like the axis here and placed it freely. And the default is pretty easy to create just by placing it next to the plot. Again, this, like how to really fine-tune this is a more advanced topic, which is covered nicely by the docs. So here you can also see like you have a lot of different options to customize these color bars with a lot of parameters. Because I already talked a lot about layouting, I just quickly want to mention a few resources for layouting, because I think Maki has one of the best layouting system out there, thanks to Julius, who wrote like a custom layouting solver to because we couldn't really find anyone that was nice enough to align things to the spines and stuff like that. So in the documentation, there's a full tutorial about how to do really complex layouts with Maki. And we also, at I think JuliaCon 22, we gave a pretty long workshop just about layouting. So if you have the need for really complex layouts, that's where to find more. But I won't discuss all these little tricks here with tell width, tell height, and stuff like that in detail in this workshop. Yes. So finally, we come to axes and blocks. So as I already said, like all axes are blocks. We have quite a few blocks. Like UI elements like button, interval slider, menu, slider grid, and so on. They are also documented, so if you search in the docs for menu, you will see how to use it, and that's how you can create little menus. I won't describe this more because I actually want to show you how to do this more complex UIs with Bonito in the web, because I think there is a large interest into actually having like a website with a dashboard and these UI elements. But yeah, you can also see there are a few more access types. There's not just the one we have been seeing right now is the 2D axis, but there's also a 3D axis. Because I already loaded GeoMarchy before the workshop, there's now a geo axis in here. If you just load Marchy itself, this wouldn't be in here. And we have a polar axis, and a little bit, this L scene is a little bit an outlier. It's our way to include a scene, a 3D scene from the legacy Marchy, basically, before Julius wrote all these crazy cool layouting things. But just to get an idea about all these different axis types, I think it needs to compile. I made a little example to just show the most used axis type. You can choose the axis type explicitly by passing the type. And of course, you can also just do like axis 3 like we learned in the beginning. But yeah, I usually use the shortcut, the shorthand. Okay, so, oh, that's a bit too big. So that's probably the most commonly used axis type. The L scene doesn't have a very nice grid. You see that the numbers are a little bit too small and things like that. We never got around to improve this a lot, but this L scene has a very fancy camera. So it's almost is like a computer game camera or an AutoCAD or 3D S-Max camera. You have a lot of keyboard shortcuts to actually move around with it. So I'm using WASD to just move around here. I think this is not very well documented because it's kind of not a lot of people know that this L scene has this complex 3D camera. But it's documented. You can actually customize it a lot with like what keyboard buttons to press and stuff like that. You have stuff like tilting the plot and rotating and zooming it. So this is the most advanced one. If you have a really complex 3D scene, that's probably what you want to use. The axis 3 is more like the axis, the default axis, in the sense that it actually squishes your data to fit into the plotting window. So it's really nice for making visualizations for a paper. And you see it has a smart algorithm to lay out the ticks, etc. So this is, I think, a lot more similar to what you use from MATLAB or Matplotlib for 3D axis. But you can't zoom into this one, so because it tries to fit the whole plot into the window, you won't be able to zoom. You can only zoom over the limits, I think. And this is Frederick added this and put a lot of work into making this nice. Yeah, that's how you can plot in polar coordinate system. Now, I've mentioned like a few plot types already, I think because they're very common, but didn't talk much about them. So they all also have like a doc string that you can query with the question mark. You can also see like that there are these two versions, lines and lines with a bang. You have some basic arguments that you can use. So you can use an array of points. You can use an array of x and y. And if you go 3D, you can add a z component. And I think this is actually a weakness of the Markey documentation right now, that this only has like these three descriptions here, because there are a lot of conversions that you can actually use, but we don't have a nice infrastructure to list them all because they're defined in function overloads. So for example, there's also stuff like circle. That you can just use any geometry type and it tries to draw a line around it. And this is not that well documented yet. I will concentrate on this, I hope, later this month. And right now, the best I can give you is that try it out, because a lot of it actually works, like a lot of types. So we defined a lot of conversions. And there are also a lot of plotting methods. So with base Markey, it's already 57. So I think it covers most of the plotting functions you're used to from other plotting libraries. There is also, in the documentation, in the reference section, you have an overview over all the plot types. So if you're ever lost, just scroll through this and find your plot. Sometimes they have a bit different names from the plotting library you're used to, but usually we try to stick to what MATLAB or Matplotlib does with the naming. I got out a few plotting types that I think are relevant for visualizing Earth data. So for example, to have this topology data of this volcano, you might want to use contour F. And yes, it also has these features to filter out like lower and higher topologies, and then create this nice plot here. Another one that I singled out here is a surface plot, which is also, I think, very relevant for visualizing terrain data. So here you can see the same volcano as an actual surface plot. And I want to use this chance to show you quickly how to actually animate and update plotting types in Markey. So you can actually just mutate the same argument names that you used before. So to change the color map, you can pretty much just do this, and then the color map will update interactively. You can also update the arguments that you gave to the plot. So in the first, it always corresponds to the argument that you passed. So if you pass just one argument with the data, you will index into the plot with 1, and then you can actually update the data. And you will see that I now added a bit of noise to this, and it will update immediately. Yeah, this updating is a bit slower in WebGL Markey than in GL Markey, but it's still pretty fast, I think. Also, like this, if you think this stutters a bit, this Access 3, I'm pretty happy with the performance, because all of the layouting and everything like this is done in Julia and then sent to the browser. So if you rotate here a bit, it will do thousands of calculations in Julia and send a lot of data back to update the plot. which is kind of impressive, I think, that we got the performance to do this. But I think in the future we want to move more things to JavaScript, so you don't need to round trip for just turning around your plot. Yeah, the L scene actually already has a little JS camera, so that one will update more quickly. Since I added this example yesterday because I talked with quite a few people that didn't know that this works. So Maki also has support for irregular surfaces. So you can give it a matrix of X and Y coordinates and then the Z one. And you can also give it a completely new color so that it's not colored by looking up the Z values and mapping that to a color map, but you can give it a completely new color, and that's how you can map, for example, the Maki logo on a surface plot, which it's more like a gimmick. And you can also set the Z to an array of zeros, for example, to make a flat 2D surface plot with irregular grids. I think a lot of people will use that in showing like Earth data that is like skewed or distorted, or satellite data. So
would that be the fastest built-in function to plot this rotated grid, this 2D surface that are not aligned with the axis? Would that be the fastest method?
which one?
This surface one we just presented? If I want to plot a rotated grid or a grid that's stretched, rotated in 2D, that surface would be the function to call to do it with maximum speed,
So surface has a bit of overhead compared to like image if it's 2D.
Yeah.
And if you only rotate the whole image,
Yeah.
image will be a lot faster. But if you need to like apply a transformation to every point, like with a projection, for example, then you can't get around surface and paying the overhead of actually, multiplying every point by a transformation.
So if you have a transformation point by point surface in the choice, and if you have just a rotation, the image supports the...
Yeah, it supports rotate, translate, and stuff like that.
Simon? Can color also be Z?
That's the default.
Okay.
So in the default, if you don't set it, color will be equals to Z. So here you
If
see
put
like
Z0
it,
and color equals to Z, then it would be something like a heat map, right?
yeah, will be pretty much a heat map. Why? I actually wanted to quickly use this chance to show a little difference between Maki and WebGL Maki. So Maki, GL Maki has a lot better transparency than WebGL Maki. We didn't have the time to show this yet. I mean to improve this yet in WebGL Maki, but here you see that's a real transparency there. If you use WebGL Maki with the transparency true argument, you will see that it looks a bit weird. And I don't know why it's so slow, to be honest. It's only the surface thing. Yeah, I don't know. Anyways, the next plot type I wanted to present is pretty new. It's a data shader implementation. It enables you to visualize billions of points at interactive speeds. And it works by aggregating all the points into an image, and then you can basically just view the image. And it recalculates the image every time you zoom in. So then you get a better resolution. This is still doing stuff. Yeah, I wanted to quickly show this with the New York taxi dataset, which has like 14 million points, which is already quite a lot for most plotting libraries. I think I might have confused it by actually wanting to show it in a window. Huh. There we go. Yeah, now it works again. And as you can see, this looks really weird because it shows the things not with real transparency. So sometimes like the front is in front of the back and stuff like that. But if you remove the transparency, true, it at least doesn't do this weird front and back thing. Okay. So for anyone who's actually following this in the notebook, I didn't ship the data set. I have it already downloaded locally because you can just download it with downloads.jl. So I won't need to download it, but it's like 500 megabytes, so I didn't really want anyone to download that much of data here on the Wi-Fi. But here you can see how to download, load it very quickly. We want to just visualize the drop-off latitude and longitude, which is like, as I said, 40 million points. And just to give you an idea of how bad it is to actually visualize 40 million points just with a normal scatter, I quickly show you this. I do it in geomarchy because I think WebGeomarchy will have a bit more trouble with 40 million points. This is, I think, here, this data set has a few outliers, but that's, I think, most of the points are actually here. And as you can see already, I gave it a bit of transparency to give an idea of the density, but it's just a big black blob, and you don't see that much. If you zoom in more and more, you can start seeing a structure here. And I think it's pretty cool that geomarchy is able to just visualize 40 million points, but yeah, it won't be, it won't look that informative in the end. So that's where data shader comes in. And that's one of the examples where it's really noticeable how, like outside Jupiter, it's actually pretty fast. And inside Jupiter, somehow, it's a lot slower. I don't know, that was unexpected. Because I actually tried data shader out with WebGeomarchy a lot when I implemented it. But as you can see, like zooming, oh, that's not too bad. But then it has all these updates that kind of come in. So with WebGeomarchy, I would just use the zoom rect plot. Wow, okay, never mind, it is bad. To get an idea how it is with geomarchy, it's a lot faster, so you can just zoom around and it works pretty well. Yes. This is a very new recipe, so we are still trying to polish it a bit. But yeah, that's a really nice way to visualize very big data sets. And this slowly transitions to how to actually add geodata plots on top of it. For example, you might want to actually have an overlay of New York on top of it. I'm using GeoJSON to actually load a feature collection of those states in New York. And you actually need to load GeoMarquee to plot them. Like I said, Marquee defines all these argument conversions for plots. And this feature collection from GeoJSON and base Marquee, you won't be able to plot it. It will just say, like, can't convert the argument. But if you load GeoMarquee, it will actually define those conversions for feature collection. And then you can actually display it. So in which backend am I? Yeah, I'm still in GeoMarquee, that's probably good. And then you can, if they're in the same projection, you can quite easily just lay it over by plotting into the same axis the geo object. And then you have it nicely overlaid. Of course, this won't work as well if you are in different projections for the data, or actually want to apply different conversions. Which brings us to Tyler, which operates in a different projection space because it actually translates these tiles into this tile projection space. But it's a nice Marquee extension to view map and satellite data from these tile providers. Just to give you an idea, there are quite a lot of tile providers here that you can choose from. So OpenStreetMap is a very famous one. I think there's also NASA on there. Some are, I think, they actually need a key because they're you need to log in and have a key for them to serve your data. But yeah, what Tyler will do, it will download from the servers the map tiles and then actually display them in Marquee. And then you basically get Google Maps and Tyler. We created this package last year at Julia.io, and Raphael put quite a bit of work into this. I pretty much was just responsible for like making Marquee work with this. And Martijn, I think, helped with the projection spaces, which uses map tiles to project from the from Web Mercato to VGS 84, and that's the default projection with Tyler. But yeah, you can also change the provider, to example, to the NASA GIPS provider, and for example, see the satellite image for the Earth at night, and get this one. So now if you want to plot into this, it's a bit more complicated because of these projections. And what you can do in Marquee is you can define for any plot type, you can define your own custom projection and transformation. What I did here is basically just copy and pasted the projection from Tyler that it applies internally onto these tiles, put them into a project function, and wrap them here in these Marquee-specific structs. So this is the point transformation type, which means the function expect as an input one single point. It's a 2D point, which you can also specify, and that's just for Marquee internally to do the right thing. And then you put it into this transformation struct, which also does the translation and rotation of plots. So you can actually call like rotate on this transform formation with a degree, for example, to rotate a plot like this. This also works like with plot objects, which pretty much just forwards these functions to the transformation that each plot has. And obviously, you can also give it this transformation function that gets applied to any point in the plot. And that's how you can actually use any marquee plotting type. I need to execute this. And then get them correctly transformed and laid over the plot. I will delete this plot for now from the axis because it just overlays over everything, and quickly show how you can, for example, overlay the Italian states, which then looks like this. And you can zoom into this. Works a bit better than Data Shader, but it's also still a bit slower than the GLMarquee version, or even the WebGLMarquee version in a new tab. So I don't know if this is my fault that Jupyter is slower, or if Jupyter does something weird, like with overwriting my library again or something like that. Yes. And of course, this updating of the plot types also works. That's universal to any marquee plot. So if you have any marquee library that defines any extension and it returns you a marquee plot, you can always just update them by mutating the plot type. Now, GeoMarquee defines another axis type, which is the geo-axis, and that's basically just a convenience for doing these projections and creating better ticks for them. It tries to create decent ticks for any projection that it supports, and which is a lot. I think, in the GeoMarquee docs, which aren't very complete, it shows most of the projections it supports, which come from geodesity, I think. So I think it supports all common projections, but that makes it kind of hard to do the ticks and labels in any weird projection. We worked quite a bit on this at MarqueeCon, and I worked a little bit on this before coming here, but it's still not perfect. But now it kind of works that you have create this geo-axis just like any other marquee axis, with the addition that you can add a destination projection and a source projection for the plot for the data that you plot into it. So that's how you can get this kind of axis. And with any plot type, you can actually also pass the source projection. So you can, into the same geo-axis, you can plot different data sources into it. So this is just the fallback, pretty much, if you don't supply this keyword. And as I already said, I'm not the expert with these projections. I basically learned about all of this at last Julia.io, and not that much has happened since then. Yeah, so I think others are well more fluent in this. But I wanted to show you a small interactive visualization using GeoMarquee, which Lazaro pointed me to, and that uses YAX arrays, which is a pretty cool Julia package to work with really large data sets. So you can give it an online source, and this one I think is 64 gigabytes large, and then you can open this data set, but you don't need to download the whole 64 gigabytes, but you can just query like subsets of it pretty much. And I already executed this because it can take a while depending on the Wi-Fi. When it was good, I think it only took like 5 seconds, so that's not too bad. It's, I think, surface temperatures. I did link the source of this somewhere. Maybe it got over, but it's in the YAX array documentation. And then you can look up the longitude and latitude in this data set that these data points are from and get the actual measurements from it. To visualize it, we had to shift it to go from minus 180 to 180. And then we can actually create this visualization. I'm introducing a new concept here that is very basic to Bonito and Marquee. It's the observable. It's pretty much like just a small wrapper around any data, which you can update and register listeners on it. So whenever the data updates, you can call a function. Or you can map it to a new one, which I will explain a bit later. So how do we do it? You can always pass an observable to any Marquee attribute. And here we have the slice of the data, so the time pretty much. We want to be able to pass the projection and the color map. That's this mapping. So whenever the slice observable gets a new number, it will call this function here, look up the index in the data, and then you get the slice data here as a new observable. So if we execute this, we can see this data set over the geo axis. I added like a plot for the coastlines. And here you can also see this translate feature because you want to put it above the surface plot, the lines, because otherwise they wouldn't be visible. So you can just translate, rotate, or scale any plot like this. And then to update these observables, you can just use the indexing notation. And this here means changing the slice index to 10 and using a new color map. And then it will immediately update in a pretty efficient way. There are quite a few documentations for how to use observables. I think it's somehow one of the more advanced topics in Marquee. A lot of people are used to just specify each frame basically and then make a new plot. But with these observables, we can just, for a whole big plot, we can change, for example, with the 40 million points, you would have this huge plot. And if you have like an observable that just changes the color, it will not redraw anything else but the color. So you can do very fast updates with it, which is the advantage. I think the disadvantage is that it's a bit harder to use. But yeah, we have quite a bit of documentation for it in the Marquee documentation. Observables is an external package that Marquee uses, which has also quite a bit of documentation how to use it. And we have some more general one, how to make animations and how to actually make interactions with Bonito as well, because Bonito also uses observables. But now we have this nice little function where you can pass attributes to it that animate the whole plot, which I think calls for a dashboard. So I will quickly walk you through how to create a dashboard from this with Bonito. I don't know, how much time do I have left? Is it more than half an hour, right? Good. So yeah, last year it was called JS Surf. It was a really bad name. I came up with that in, I think, 2018, and I thought, okay, this won't be used in like a user-facing, so I just gave it whatever name, but then it turned out that people want to make actually more advanced dashboards with it and use it to write HTML and JavaScript in Julia. So I wanted to rename it for a long time to give it a nicer name, which I've finally done 3 weeks ago. So if you see JS Surf somewhere still mentioned, I probably haven't updated all places of the whole ecosystem to mention now Bonito. But yeah, it's the workhouse behind WebGL Marquee that I created back when I started working on the WebGL Marquee backend, because there was no good way in Julia to communicate with the browser and actually render HTML and things like that. And yeah, I put quite a bit of focus on a performant communication with JavaScript. So it uses, it tries to compress the data as much as possible and uses binary serialization to make them as small as possible, the messages that get sent from Julia to JavaScript, which allows quite a bit of speed. Also, the other thing I really wanted to have is that it can be rendered in any context, so that you can easily define one app and then just put it in a notebook, put it on a website, or even put it into a static website, like into the documentation or things like that. The Marquee website is actually created with Bonito, which then uses the functionality to export static websites. So it can be used for pretty complex projects. The basic is this app block here, where you define what you want to send to the browser. It uses this DOM module to access all kind of HTML tags. So I think if you try the autocomplete here, okay, Jupyter doesn't like this. Well, anyways, these are just the normal HTML text you can get a lot of tutorials for. It defines a few components, I would call them, that you can just call into, that creates HTML and CSS, for example, to create a centered headline. And of course, it works well with WebGL Marquee, so you can just, into this DOM, into this HTML DOM, you can just put any Marquee figure, and it will turn up in there, and will also be interactive, just like you're used to it. It also has a bit of infrastructure for styling the HTML, because it's kind of cumbersome to write an external CSS file. It also works, you can include an external CSS file, so you can also use like existing CSS libraries like Tailwind. But I think if you want to create components, it's really important to have a simple way to style things. It's really just mapping to CSS, but it of course has to use Julia syntax because you're creating it in Julia. It makes it really easy to make reusable components, because you can just do like button and then give it like a custom style for your component. And the beauty here is, for each app, Bonito will only render out one style sheet. So if you include the same style a lot of times, it won't include it in the website a lot of times, which is very important for this to work. you can also give it like these CSS hover pseudo classes to, for example, do something on a hover and change the style there. And I actually use ChatGPT a lot with this because it's really good at just taking existing CSS and translating it to the Julia syntax. So, for example, what I've done a lot here, oh, it's really small, is like you need to kind of explain to ChatGPT what the syntax is like, but something like this is enough. And then you can just say, please translate me this piece of CSS I found on the internet to the Bonito kind of syntax. And I also, then you can just tell it to like, please give me a style to make a button that turns red on hover, and it's actually pretty good at that. So especially for me, I'm not a CSS expert or JavaScript expert. This has helped a lot to style things. Yeah, this is how you can actually then style the app. And as you can see, it has a different font. It has a font size here and turns red if you hover. All of this is also explained in the doc strings of these components in Bonito, how to style it and how to actually work with it, because you want to react on changes of these widgets. As you can already see here, this button widget has this value, which is an observable. So you can register a function on it, like every time the button changes, please call this function here. So, and the other widgets also should have this documentation, so you can really make really nicely styled apps with that. And I just want to quickly show you how this works with observables. This map function I already explained, so every time the slider changes here, you add an +1 to it, and then in this new value, you have the slider value +1. And that's, for example, how you can show this here. Bonito supports putting observables anywhere, so into the DOM. So here I just put this new value directly into this grid, and then it will render inside the HTML and will update accordingly. And print out a lot of text, because I also showed you the on function. Yes. Oh, did I make a shortcut to run the whole notebook? Sorry. Okay. Yeah, so Bonito has quite a few of these widgets, like the stylable slider, the button. It has a drop down, and quite a few more widgets, which you can see in the docs. So you have a text field as well, number inputs, and this card thing, so you can nicely group things together, and have these stylable sliders, which you can put your own styling on. And yeah, this shows all of them together in a layout. And it also has a lot of layouting primitives to create a very complex layouting. I actually recently ported a very cool tutorial that explains how to do layouting in CSS. It's a very fancy layout tutorial that goes into depth to create really nice layouts with very nice visualizations. I did a bit simpler version of it, but it's still interactive, so it shows you how to really do complex layouting and explains all the different concepts like how to align things. And it was also really helpful for me because, yeah, I'm also just starting to learn CSS, but this interactive thing really helped me to be able to create these different layouts. I think whoever wants to create a nice dashboard should really read through this tutorial. I'm not sure if it's relevant to everyone here, so I'm just using this grid here, which is the main component to do these complex layouts. And have it as a given here to create this layout, for example, to make a slider, a button, and a drop-down. You do need to use Bonito for the easiest way of making a dashboard. We have been talking with the Jenny developers to incorporate it, which is possible, but nobody has worked on it. And I think, yeah, you could probably hack around it, but it's not easy out of the box. Would be a project for me, I guess, to make that work. But you can actually, Dash is an alternative, so dash.jl to Bonito. I think you could probably inline WebGL marquee plots in there, so you can actually do it. Yeah, but I haven't tried it yet. This also gives you most of the power of CSS and HTML to do these nice dashboards. Already had this. Oh, damn. The interrupt wasn't very good. Now that we have this basic here with the slider and the observables, I just want to quickly show you how it works together with Marquee, because Bonito uses observables, Marquee uses observables. It's then very easy to animate things with Bonito and Marquee, and it should be pretty efficient. Coming back to this Earth visualization, I think we now have everything in place to actually use those widgets to update the visualization of the Earth data. It's a bit larger app because it also creates this header and the widget grid. I added some titles on top of it so that you I think this is so much bigger because I tried to set the font size. Oh no. Why did it reload? Yes. I don't know why I just reloaded the notebook. But now like this, you have these widgets which you can change the projection and the time of this animation. And finally, I want to show you how you can actually deploy these apps into different contexts outside the notebook. Because yeah, the notebook use case is actually not the first class use case of Bonito. That's also, yeah, I'm not using it that often with the notebooks. That's why all these things are happening. But in Bonito you can create a server, and then it shows you where it's hosted and running. You can click on that link and you see that there's no root added yet. And that's where you can add your app. So if you already have like a Bonito app, you can add it to the most basic root, for example. Oh, I have way too much open here. And this way your app will end up here on this localhost website. And that's how you can pretty much ship it. And here you can also see that it's a lot faster than in Jupyter. It's basically instant, and in Jupyter it was lacking quite a bit. It also doesn't get the CSS overwritten by Jupyter, and works quite a bit better. Now, if you want to actually run this on your server, you most likely don't have users go onto a local host. You will route it to your website, right? And that's where this proxy URL comes into place, which you set to your website. And I actually made some Bonito demos that I run on my own server. And I can just quickly show you how that will look like. VS Code has this really nice interface for SSHing into a server, which I'm using a lot. So I can just open a new VS Code panel that runs on my server. And the Julia plugin also allows you to make this session, the Julia session, persistent. So when I close VS Code, the server will still be running. And here, oh, it's probably way too small. Here you can see the code to set up server as you've seen before. I have created a few apps here that I include in these files, and then you can add them to the server with this root function. And this actually runs in Germany, and now you can access it on this site. And it seems like, yeah, it works now. I think the internet is really slow. Yesterday when I tried it was pretty much instant. On the right Wi-Fi. Yeah, I don't know. But it still is pretty interactive, even though it runs in Germany and now needs to get here. So you can just ship these kind of apps then on the website. And it's pretty interactive, so you can just add a new root interactively here. So if I just want to have like a new page, hello, for example, I can just give it a new app here. Probably better to have it And then you should be able to go here and see this new app. So that's how you can kind of develop your Bonito server and web page. So yeah, the next thing you can do is like do the export, the static export, which I've been using for the Marquee website. And that looks like this. You will need this new type to create the routes, because you don't actually have a server to add the routes to. And then you can export them all into a folder. And then any server that serves like HTML files will be able to make a website out of this. So in GitHub, this will be just in the pages folder that you use. Live server, you can just give a folder and it will create it will host it as a website. So I'm using live server here to then serve this, and you see you have the app here as a static export. The big difference, of course, is for the static export, you only have HTML files and no Julia server anymore. So any interaction that was defined in Julia won't work anymore, which is, of course, a pity, but there are a few workarounds to keep things still interactive. Like, for example, the 3D camera for the L scene in in Bonito or WebGL Marquee lets you still interact because it's actually written in JavaScript. So if you have like a 3D scene, it will be still interactive. And anything you actually wrote in JavaScript will stay interactive. So I did this little example here in the documentation, which does the updates in JavaScript and the calculations. So things like this stay interactive even without a running Julia process. And the WebGL Marquee docs also have a few examples here where you can see what's possible to keep interactive on the static documentation side. So for example, there's this record state experimental feature that goes through all the widgets you have in the DOM and then pre-records all Julia values, and that lets you still interact with this. But it creates pretty large files because it needs to cache all the combinations of states that are possible. So it doesn't work for all cases. Yes, any questions for this? Yeah.
Regarding the development of Bonito compared to other dashboards like that of Java and other ones, do you have a specific motivation to make it like specific to Mackie and be more performant? What's your main rationale for it?
So the main rationale is performance and using observables, because I think a lot of the other frameworks are using diffing to update like the HTML and attributes, which always needs to traverse the whole tree and figure out what's different. And with the observables, you can directly only update the attribute that you're updating. And the protocol is pretty advanced. I don't know of many other libraries that actually use like the binary compression and stuff like that, so it's pretty fast. And one big other thing is the components, that you can actually in Julia create new widgets for Bonito. So I really hope that will create a rich ecosystem of stylable components. If you look at Bonito, you can see that these components are actually relatively simple. They just directly pass the attributes forward to CSS and HTML, and then anyone can use them and use them in the dashboards. And one of the big frameworks before Bonito in Julia was Web.io, and that didn't allow you at all to do these component things because you always had to have the whole app. So if you wanted to style something or interact with something inside this component, you basically had to pass the whole thing in there, and then it wouldn't be modularized anymore. It would be specific to the app that you wrote, and that's a big difference. Okay. Thank you. That's what I wanted to show. And any discussion? Thank you.
Okay, so it's lunchtime. You already know what it is. We'll be back at 1. For those who are online, have a good lunch and see you at 1.